Hi, I'm Nick Case and I work here at Marshall Space Flight Center in the Propulsion Systems Department. And today I'm going to talk to you about our additively manufactured demonstrator engine that we currently have built up here at Test Stand 116. This is what we call a breadboard engine configuration. And so a lot of it is all spread out to give us more room to put instrumentation and specific sensors to try to get as much data as we can on our additively manufactured parts. And I'll start off with our fuel turbo pump. So this pump is for liquid hydrogen, and that is at minus 423 degrees Fahrenheit, and it produces over 2,000 horsepower, spins at 90,000 RPM, and the majority of all these parts here are additively manufactured. The only things that we don't have are seals and bearings, and we just completed 15 tests on this component, and now we're ready to incorporate it into the engine. Over here we have our main fuel valve, and so what this valve does is it allows the liquid hydrogen coming out of the turbo pump into our mixer, which is also additively manufactured, and we are able to mix liquid hydrogen and gaseous hydrogen together to send into our injector, which is behind here. That injector is also additively manufactured, and it's one of the largest injectors that we've ever printed here at NASA. On the back side of the injector is our ablative chamber, and this will allow us to do a short duration test, and it's pretty cheap to make and helps us with schedule, and so we'll use that for our first test series. We also have a regeneratively cooled chamber that is being 3D printed right now that we'll use for our later test series. Over here on the other side is our oxygen system. And it starts with the main oxidizer valve back here, which is 3D printed. We currently don't have a oxygen pump on the system. That's currently being built right now. We're using our pressurized tanks in the facility to provide our flow for the oxygen system. Downstream of that is our turbine bypass and turbine discharge valve, which will take the gaseous hydrogen from the turbine and discharge it out through this nozzle for our test program. And so this valve and this bowl are both 3D printed. So overall, this additively manufactured demonstrator engine contains over 75% additively manufactured parts for a future rocket engine design, and we intend to test this breadboard engine for a total of 10 tests in liquid hydrogen and liquid oxygen, and in the future we'll do 10 tests in liquid methane and liquid oxygen.